Can the Drake equation tell us if aliens are real? Are aliens real? The Drake equation is a scientific formula that uses math and logic to estimate the answer to one of humanity's biggest questions. How many alien civilizations might exist in our galaxy right now? It starts with the number of stars, multiplies by how many have planets, then asks, on those planets, how often does life begin, evolve intelligence, and reach out to the stars? In this video, we'll walk through the equation step by step and see what the numbers really tell us. How many stars in the galaxy? The first step in the Drake equation is the number of stars in our galaxy. Astronomers can't count them one by one, so they examine patches of the Milky Way with telescopes like Hubble and Gaia, using different wavelengths to catch even the faintest stars. Then they scale those samples up to the whole galaxy. Across many studies, the consensus is clear. The Milky Way holds between 200 and 400 billion stars. That's hundreds of billions of chances for planets in just one galaxy. How many planets could support life? The next step in the Drake equation is asking, how many of those stars have planets that could support life? The big discovery of the last decade is that planets are everywhere. The Kepler telescope showed us they're not rare gems, they're the rule. So for our calculation, we'll keep it simple and assume every star has planets. But not all planets count. The ones that matter are rocky worlds at the right distance from their star, with the chance for liquid water. Observations suggest roughly 25 to 50% of stars, similar to the Sun, host a rocky planet. To be conservative, we'll call it 1 in 5. Now for the math. 200 billion stars times 1 in 5 equals about 40 billion potentially habitable worlds in our galaxy. How many planets have life? In the last step, we estimated there are about 40 billion potentially habitable worlds in our galaxy. The next step is asking, on how many of those planets does life actually appear? On Earth, life showed up quickly once conditions settled, within a few 100 million years. That suggests life may be a natural outcome when the chemistry is right. Scientists debate the exact odds, but many argue it could be close to 100%. To stay conservative, let's say only 1 in 10 habitable planets actually develop life. Now we do the math. 40 billion habitable worlds times 10% equals about 4 billion planets with life in the Milky Way. At this stage, the Drake equation counts life in the broadest sense, even single-cell organisms. How many develop intelligence and communication? In the last step, we estimated about 4 billion planets with life in our galaxy. Now we ask, how often does life become intelligent, and how often does it learn to communicate? On Earth, intelligence hasn't been a one-time accident. It's appeared again and again across the tree of life. Mammals like us, birds such as crows and parrots, octopuses, even reptiles and sharks can have advanced hunting strategies. And if you look at insects, ants have agriculture and complex societies that rival some human systems. All of that tells us intelligence isn't unique. It's a survival tool that nature keeps reinventing. But advanced technology is another leap. To stay cautious, let's say only 1 in 1,000 life-bearing planets produces a civilization that can send signals. Now we do the math. 1 billion times 1 in 1,000 equals about 4 million intelligent civilizations in our Milky Way galaxy. Aliens are real, so where are they? So what have we found? We started with 200 billion stars, narrowed down to 40 billion habitable worlds, then 4 billion planets with life, and finally about 4 million civilizations capable of communication. Even with cautious numbers, the Drake equation says our galaxy is alive with intelligent beings. That's the answer to our question. Are aliens real? Based on our best observations and reasonable estimates, the math says yes. But maybe what you really want to know is this. Could aliens have already come to Earth? Out of millions of civilizations, how many might have spread across the stars and reached our solar system? That's where we'll go in parts 2 and 3 by extending the Drake equation to the next logical steps.